A culture of bacteria grows in number according to that equation, where t is in hours. Determine the rate of bacteria growth at 10 hours. Okay, so what this is saying is find the derivative, plug in the value of 10. So, let's see, we need to find n prime of t. This feels like an appropriate color for bacteria. I'll start by just rewriting n of t. So we have 3,000 plus 12,000 t over t squared plus 100. And we need to find the derivative of this. So this right here is going to be the product rule. Some people use the quotient rule. I disavowed the quotient rule, eschew, if you want to use an obscure word that's useful for various standardized SAT type tests. I just use the product rule. So I will rewrite this as n of t equals, I'm going to still leave in 3,000, even though I know that once I do the derivative, that 3,000 is going to go away because it's a constant. So we still have t squared plus 100 to the negative 1. Okay? So then we will have n prime of t equals 12,000, because that stays the same. Now we do the product rule, where the product rule is uv prime equals uv prime plus u prime, prime v, where u will be t and v will be the other one right there. So try and do this all in one fell swoop. We'll have t, check, times this prime, so that will be negative 1 times t squared plus 100 to the negative second. That's the power rule. But we have to do the chain rule too, which means take the derivative of the interior, or multiply by the derivative of the interior, which will be 2t. And then we add, this is 12, u prime v, so it'll be 1 times t squared plus 100 to the negative first. Okay? So simplifying, we have, change colors because I have grown wary of green and it doesn't accent well enough. Okay, so we have 12,000, and I'm going to do this one first because there's a negative on this guy. So we'll do 1 over t squared plus 100, plus minus, let's see, it looks like 2t, 2t squared over t squared plus 100. And this should be squared. Okay? Hope, probably have most. Now we'll combine them. We'll combine the denominator, the left side and the right side, equals 12,000. So to get it, we're just going to have to multiply by t squared plus 100. So we'll do t squared plus 100 minus 2t squared all over t squared plus 100 squared. Okay, now this is the derivative of n prime of t, which is the rate of bacterial growth. So given this rate, we want to find, this is in hours, find it for 10. So what it wants us to do is plug in 10 for the rate of growth. So n prime of 10 equals, so we're going to have 12,000, and then on the bottom we're going to have 10 squared is 100, 200, so we'll have 200 squared And then on the top, we'll have, so 10 squared is 100, plus 100 minus 2 times 100. So what this gives us then is 0. So n prime of 10, this part's irrelevant because that part right here is 0. Whoop. That came on quite suddenly. Well, that escalated quickly. Okay, so what happens here then, let's see if that's a possibility. Yes, 0 bacteria per hour. Maybe 0 bacterium per hour. No, I think 0 is plural, so it's bacteria. Okay, so what happened here was we're given an equation. They're like, all right, here's an equation modeling some sort of something, something, something. We want to find the rate of change of that. And so we did that. We had this 1 here, which ended up just going away, because when you take the derivative of a constant, it just goes away. But then we had a t over t squared plus something. And the trick with that was you do the product rule. Or you can use the quotient rule. I'm a fan of just using the product rule and viewing it as a negative 1 exponent, and then you still have to use the chain rule then. So, does it save you time? It's a longer process, but you have to memorize less. And from there then, I simplified a little bit. One of the key parts of simplifying was I combined the denominators. So we had basically a denominator which was not squared and the denominator that was squared. You combine them and write out an equation. And then you take that equation and you plug in the value that you were given. Turns out then that when you plug in the value of 10, everything on the numerator cancels out, giving you 0. And that gives you the answer of 0 bacteria per hour. That's the idea of how you do a rate of growth question.